Hello everyone, welcome to Chemazon Complete Chemistry. So in our today's video, we are going to learn a very important topic, that is nomenclature in alkenes, that is Cis-Trans and EZ nomenclature. So let us first understand how a bonding takes place in an ethene molecule, that is a carbon-carbon single bond or sigma bond is formed first, and then how a pi bond is formed. So we all know that an excited state carbon has got 4 unpaired electrons, out of which 2 are involved in this carbon hydrogen bonds, whereas the third one is involved in carbon-carbon single bond, and there is 1 electron remaining in this unhybridized p orbital, which will overlap with this p orbital of the another carbon, and that's how a pi bond will be formed. So let us see how the pi electron cloud of an ethene molecule looks like. So this is how a pi electron cloud of an ethene molecule would look like after a pi bond is formed. So let us now understand some very important topic, that is substitution in alkenes. What do we mean by substitution? How substitution takes place in alkenes? This is a very important topic to understand some basic rules, that is Markovnikov's rule, anti-Markovnikov's rule, whereas in organic reaction mechanism we will study Seitzeff's rule and Hofmann elimination rule. In all these rules it will be very important for us to understand how substitution takes place in an alkene molecule. So here you can see this is a ethene molecule where this is carbon, double bond carbon, and the 4 hydrogens are attached to it. Now let us see monosubstituted alkene. What do we mean by monosubstituted alkene? Mono means one, substitution means replacing one group by another in an alkene. That's why it is called as monosubstituted alkene. So here in this example you can see I have replaced this. Previously it was a hydrogen, I have replaced that hydrogen with a fluorine atom. So that's why it is called as monosubstituted alkene, and this is how it will look in a ball and stick model. Disubstituted alkene, 2 hydrogens of alkene molecule are replaced by 2 different groups, that is fluorine and bromine. Then now let's see what is trisubstituted alkene. 3 of the hydrogens of the ethene molecule are replaced by fluorine, bromine and chlorine. And finally we have tetrasubstituted alkene, where in an ethene molecule I have replaced all the 4 hydrogens with this different groups, that is fluorine, chlorine, bromine and iodine. So now let us understand what is cis-trans isomerism in alkenes. So before understanding cis-trans or EZ nomenclature, it is very important to understand this concept of reference plane. What do we mean by reference plane? You can see this solid line or the box. You can consider this as one plane containing this carbon-carbon double bond as well as these 4 different groups, that is A dash, B and B dash. All these atoms and bonds lie in this one plane, that is a plane containing the double bond and its 4 ligands or different groups. So what is a reference plane? You can see here there is a dotted plane which we call it as a reference plane. This is very important to understand the concept of cis isomerism, trans isomerism and EZ nomenclature. So now let us understand what do we mean by cis isomerism. As we saw in the previous slide, that here will be our reference plane. So you can see these 2 methyl groups in this molecule called as cis-2-butene. Both these methyl groups are above the reference plane. So we can call these 2 as cis to each other. That's why it is called cis-2-butene. Why 2-butene? Butene because the parent chain has got 4 carbons, and if we start numbering from here, at the second carbon you can see there is a double bond, and since the groups of are cis to each other, that's why they are called as cis-2-butene. Similarly, let us see what do we mean by trans-2-butene. In this example you can see that the methyl groups are in opposite direction to each other. in terms of reference plane, you can say that one methyl group is above the reference plane and the other methyl group is below the reference plane. And this is why we call that two similar groups on opposite sides, then they are called as trans to each other, and this is called as trans to butene. So this cis-trans nomenclature is okay up to 2 substituents, but it becomes really difficult to understand cis and trans nomenclature in trisubstituted and tetrasubstituted alkenes. So in that case, we understand or learn the EZ nomenclature. What is this EZ nomenclature? As in RS nomenclature, or they were also called as CIP rules, that is Kahn, Ingold and Prelog rules. Similarly, in alkenes having 3 substitutions or all the 4 substitutions, we use this concept of EZ nomenclature. Now let us understand what do we mean by this. So E stands for Entgegen and Z stands for Zusammen. What do we mean by this? The first step is at the terminal carbon where the 2 groups are attached on either side, this side as well as this side. What we have to do is we have to use our basic CIP rules, that is what we did for RS, that we have to assign priority to the groups on the basis of atomic number. Here, let's say this is the first priority, this is the second priority. Similarly, on other side we have first and the second priority based on atomic number. So when the higher priority groups, that is 1 and 1, are on the same side, that is both these groups are above the reference plane, then we call it as Zusammen or Z nomenclature. Similarly, if the higher priority groups, you can see here, they are opposite, or one group is above the reference plane and the other group is below the reference plane, then it is called as Entgegen or E nomenclature. So now let us understand and give a little thought of how to remember this. So you can remember this by this trick, that is egg open, where egg you can remember it as the E nomenclature and opposite. So E is when the higher priority group according to atomic number are on the opposite side, or one above the reference plane, one below the reference plane. So egg open, E opposite. So in this way you can remember, and accordingly the Z nomenclature will be Z, that is higher priority groups on the same side. Now let us understand this EZ nomenclature in a much better manner with this example. Here you can see on one side of the carbon you have bromine and chlorine. So we all know that bromine has higher atomic number than chlorine. Accordingly, we number bromine as 1, chlorine as 2. And similarly, methyl and hydrogen, we number methyl as first priority and hydrogen as a second priority, as carbon has higher atomic number. Now you can see the higher priority groups are above the reference plane, or we can call in the same side or cis to each other. That's why it is called as Z nomenclature or Zusammen. Let us understand this in a much better manner with one more example. Here you can see this carbon chain of 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon chain, that's why it's called as octa. And then there are 2 double bonds, that is on the 3rd position and the 5th position. That's why it is called as octa 3,5 diene. Why diene? Di stands for 2, ene stands for alkene. So octa 3,5 diene, and at the 3rd position you have bromo group. So 3 bromo octa 3,5 diene. Now we have to understand what will be the nomenclature at these 2 double bonds. So let us understand first at this carbon number 3. On this side, if you see, there is this bromine group attached and this is the ethyl group attached. So we know that bromine has higher atomic number, so this will get the first priority, then this carbon will get the second priority. Accordingly, if you see on this side, you have this carbon and there will be one more hydrogen. So this will get the first priority. So this is first here and this is first here. So this is Zusammen or Z nomenclature. That's why it is written 3Z. Then we put a comma, and then let us see at the fifth carbon. Fifth carbon, again let us see on this side. Here there is hydrogen, here there is carbon, so carbon gets 1. And on this carbon you can see this is attached to another carbon and one more hydrogen, so you can see this is 1 and this is 1, which are opposite to each other. That is one above the reference plane and this carbon below the reference plane. That's why this double bond gets 5E. So that's how the name is 3Z 5E 3 bromo octa 3,5 diene. So these are some of the references that I used. Thank you so much.